Hey everyone, today I've got something massive. Ever wondered what would happen if AI got 10 times, 100 times better than it is right now? I sat down with Dr. Bergen, a leading AI researcher from UC San Diego, and what he revealed will absolutely blow your mind. In this video, we're going to talk about why GPT-4 is already ancient technology, the final barrier AI may never overcome, will you have a job in 5 years, and the shocking truth about AI hallucinations. Let's dive right in and make sure to watch till the end for his most shocking prediction.
I'm a faculty member at UCSD, so I'm in primarily in linguistics, and I also have an affiliation in computer science here. And I'm a computational linguist by training. I develop computational models for natural language, and these days most of my research is related in some ways to large language models.
Ever wondered how these AI systems got so smart? Dr. Bergen reveals the 3 key levers driving this revolution, and why we might hit a brick wall sooner than we think.
There have been 3 levers. The amount of data that you have, the size of your model, and the amount of computing power that you're using. And computing power is usually standard ways of measuring this in terms of the number of operations that you're performing.
What's mind-blowing is that researchers can actually predict how much smarter AI will become according to these 3 factors.
They're called scaling laws. So these scaling laws allow you to predict how much better your model is going to get as you scale out these 3 different factors. As you add more data to your model, to the training, as you make your model bigger, as you throw more computing resources into the model, how much better does your model get? And we've been able to predict very accurately what model performance will be as these 3 factors are increased.
Here's the crazy part. Each iteration requires exponentially more resources. Dr. Bergen explains why tech giants like Microsoft are building data centers that are worth as much as $100 billion.
To get the same improvement in model performance, as your models get bigger, you need to increase the size of your model by a factor of 2. Similar for data, similar for compute. If you want the same amount of improvement, you need to have a multiplicative amount of the inputs. And what this means is that every round of improvement for these models gets more and more expensive. It's exponentially more expensive. If to get 1 unit of improvement last year, your model cost $1 million. Now to get the same improvement this year, your model will cost $2 million. To get the same unit of improvement in the next iteration, it will cost $4 million.
The most shocking revelation from our interview? We might actually be running out of high-quality data for these AI systems. Dr. Bergen drops a bombshell about the limitations of AI growth that we're seeing on the horizon.
So if you were a company and you wanted to vacuum up all words that you could that were written by humans, and how many would you have available for you if you really went to extreme lengths? And the numbers that I've seen are somewhere between maybe 100 and 500 trillion.
That sounds like a lot, right? But here's the mind-blowing truth.
Remember that we need exponentially more data in order to get the same amount of improvement. So that gives you maybe a few more generations of model improvements where you'll have enough text to get those improvements. But after that, people have been uncertain about what you're going to do then.
You heard that right. We might only have a few more iterations of AI improvements before we hit a wall. But researchers found an ingenious workaround.
So there's been a new dimension added here, which is how much computing power your model uses after training. So for processing a piece of text, for processing a question after the model has already been trained. If you asked Einstein a physics question, but you only gave him 30 seconds to answer, you were not going to get the theory of general relativity.
Right.
He wasn't going to generate that for you. A large fraction of major human discoveries have been made from careful thinking over an extended period of time. We've been finding scaling laws for this. It's called test time compute. So you reliably get better performance as you allow these models to think for longer.
While big tech companies are spending billions of dollars on massive AI systems, there's a parallel revolution happening in AI efficiency. Will the smaller players stand a chance against the tech giants?
Even since we've entered the large language model paradigm, like starting in 2020, um, uh, the cost of training has gone down very, very rapidly. A lot of that has involved figuring out how to make models smaller while still maintaining the same performance, because smaller models are cheaper. They're called algorithmic efficiency improvements.
Mm-hmm.
And every year you're getting a factor of 2 or 4 improvement in algorithmic efficiency. So GPT-2 was considered a large model at the time that was released, I think in 2019. It cost a non-trivial amount of money, and now it can be trained in literally minutes
Wow.
on normal cloud hardware.
But here's the catch. By the time smaller labs catch up to frontier labs, the giants will have already moved on to a whole new level.
Labs in a few years will probably be able to train a GPT-4 level model on their own. That seems pretty plausible to me, like a well-resourced lab. And that would have been sort of unbelievable several years ago to try to train a GPT-4 level model. So they'll be able to do that, but there will be a GPT-6 or 7 level model by the time that they're able to do that.
We've all seen AI systems be flat out wrong. This phenomenon is called hallucination, and it's one of the biggest problems in AI today. I asked Dr. Bergen if this problem will ever be solved.
My own subjective experience is that hallucinations have gone way down with the best models. If you just look at like how do models today compare to models 2 years ago, they're way better. Like in terms of hallucination. So it seems like we're getting better.
But the reason why AI systems hallucinate is even more fascinating.
My guess about hallucinations is that they're coming from 2 places. So one is just failures of memory. Like I hallucinate a lot. If you put me on the spot about something and you told me you have to get, like I have to give an answer, I will hallucinate a lot.
Right.
I have my memory fails in various ways. These models may not be sort of perfectly calibrated about when to say that they don't know things. The other possibility is that, and like the more fundamental one that's been identified in the literature, it's very, very hard for the models to distinguish between fact and fantasy. They're showing some random Wikipedia article about something that happened in medieval France in a small town. It's never seen this before. It's not connected to anything else that it's seen before. But it's being asked to predict this data.
Right.
From the perspective of the model, like, how can it predict this random fact that it occurred? Right? You're asking it to predict this random fact, but this random fact, it doesn't hang together with anything else in the world. It's just like something that happened.
Right.
So from the perspective of the model, that's no different than just a hallucination. So like during the training phase, you're almost training the model to hallucinate because you're asking it to predict all of these random facts.
Many predicted that AI would have replaced doctors by now, but that hasn't really happened. Dr. Bergen explains the unexpected obstacles that we've faced.
There's a bunch of interesting features of medicine that make it different than other areas. High quality data is very expensive and difficult to obtain. There are a lot of restrictions on how you use data because what you care about is patient data. Generally, you want to help patients, so you care about patient data, but there are privacy restrictions. And so it's very hard to get a big pool of patient data. There's been a lot of excitement about using AI in various areas, and it's real. Like there are real applications, but there were famous claims from almost 10 years ago now that radiologists would be replaced in 5 years, and obviously they haven't been. It does not look like it's imminent that they're going to be replaced.
Right.
The sense that these models maybe have not performed as well as you would have hoped, I think it's been because of data access issues.
And even if we solve the technical problems, there's another massive barrier.
Even if you had great models, there are some factors that prevent them from being adopted. There's also, for security and privacy reasons, there's very complicated IT requirements within hospitals and medical systems that make it slow to adopt the best AI technology.
Forget chatbots for a second. The most groundbreaking application of AI might actually be in biology labs. Dr. Bergen reveals the potential for AI to revolutionize medicine.
AI for science, and in particular AI for biology, is going to, I mean, it's already starting to get a little bit big. Sequencing data, so, information about DNA, RNA, proteins, it looks a lot like, in the end, natural language they use for large language models to this type of data. And the early results from this look very promising. People are able to make predictions about the effects of different genetic mutations, or the dynamics of cells, or dynamics of biological systems. They've been able to make these predictions better than they were able to make them before.
The implications for medicine are mind-blowing.
If a patient has a mutation in this part of their genome, what are going to be the effects? Right now, the way that you do this is that you have a model biological system like a mouse, and you introduce this mutation there and you see what happens. But this is slow. You can only do this on so many mice, and mice are not humans. So there could be issues with transfer of what you learn from mice to humans. So if you have like accurate, high throughput biological simulators, it seems like there's a very good chance that we'll see some advancements in biology as a result.
Now, for the question on everybody's mind, what about our jobs? Dr. Bergen's answer might surprise you.
So if LLMs continue to develop at the rate that they have been, like if this technology continues to scale, and we're able to continue to make lots and lots of chips to train and use these models, then there's a question about what are the unique human cognitive skills that will remain unique in this 10-year timeline. There's some aspect of what humans do that we don't figure out how to automate, in which case humans will still be necessary for the jobs that they're currently performing. They'll just be made more productive. So this is like a view of like AI or LLMs as productivity aids, productivity enhancers. That seems like actually a very good outcome in a lot of ways. But there's a possibility that the fraction of these unique cognitive skills that humans have, it starts going down. And what that means is full automation of an increasingly large number of jobs. What would be the reasons for still having jobs in these areas? I think there's two, basically. One would be inertia, like companies just not adopting the technology because companies are slow in various ways, or organizations are slow in various ways. There's a lot of inertia. Maybe things could change, but they don't. And the other reason why these jobs would remain would be regulatory. There could be laws. There are currently some laws in some areas saying that a human licensed in a specific field has to at least sort of have the final say on anything that's done.
Dr. Bergen revealed yet another potential threat of AI.
I'm concerned about, or not so happy about, substituting for human relationships in various ways. So, models are much easier to deal with. Unless you specifically ask it to, it won't get angry at you. And if you're being unreasonable, it will not necessarily tell you. It hasn't happened, I'd say, to the extent that I maybe would have predicted that it would, given current LLM capabilities. So that's a good sign. But yeah, I'd say at least a concern for the next couple of years would be more of that happening.
Dr. Bergen's insights give us a rare glimpse into where AI is really headed, both their incredible advancements and the challenges ahead. Here are our key takeaways. AI improvement follows predictable scaling laws but requires exponentially more resources. We might be approaching a data bottleneck for training high-quality models. New thinking time capabilities may be the next frontier of AI advancement. Hallucinations are decreasing but remain a fundamental challenge. Applications in biology show enormous promise despite regulatory hurdles. This is just the beginning of the AI revolution, and we'll be covering every breakthrough right here on VCHQ. What do you think about the future of AI? Will it take our jobs or create new opportunities? Let us know in the comments below. And if you found this video mind-blowing, smash that like button and hit subscribe to stay up to the cutting-edge technology on the horizon. The YouTube algorithm loves it, and it helps me bring more content to you guys. Until next time, this is Alex from VCHQ, signing off.